Hey everybody, so this is Mr. Buzz here, and we are working on Precalc A section 1.6 on transformations. And this is kind of a little bit more of the book definition of some of the stuff that we're going to do right now. And we're basically going to talk about how do I take something simple like a parabola and make it wider, make it narrower. I use those words a lot: move it up, move it down, flip it, upside down, all of those different things. So transformations. But some of the stuff in the book and some of the things that you might see gets into a little bit more detail. So I wanted to give you this chart. So if you guys can put this in your chart, that'd be great. So if we take any function and we add or subtract directly to the x, that's going to move the function left or right. And if I add to it, it's actually going to move it left. And if I subtract inside these parentheses, then it's going to move it to the right. I think you guys know that from most of the stuff that we've seen before. If I add or subtract something outside of a function, so here's my function f of x, whatever that function is, and I add or subtract some constant to it, that's going to move the entire function up, the entire function down. If I put a negative in front of the entire function, I negative all of those things, it's going to flip it over the x-axis. I do a negative directly to the x, the input of the x, change all the x's. That's going to flip all of the function over the y-axis. And if I do it for both of these, the negative, the function of the negative of x, that's going to go through the origin. Okay. I rarely use this verbiage in this class, but I know that the textbook talks about it. So just giving you a quick little example. If I multiply an entire constant to a function, that k is greater than 1, that's going to be considered a vertical stretch. And if that k is less than 1, that's going to be considered a vertical shrink. So vertical changes when the constant is multiplying to whatever that function was in its entirety. And then horizontal, and we're going to call it too, horizontal stretches or horizontal shrinks. If the k is inside, directly affecting the x when the k is greater than 1 or the k is less than 1. So we're going to look at a lot of these different things, and I'm going to kind of go back up here. So here's a bunch of different functions. So when we talk about these ones, we want to talk specifically about first, what's its root function, what's its, or what we'll call its parent function. So this one, its root function would be y equals x squared. And remember, you can pause the video and copy down any of these things that you want. So y equals x squared. And then there's a bunch of things that are transforming it. This one again, y equals x squared, y equals root of x, y equals root of x. And try not to get too crazy on you on some of these things. This one up here again is y equals x squared, y equals x squared, y equals root x, and then I want to throw in a few other ones here towards the end. So y equals absolute value of x, and then y equals sine x or cosine x, tangent x. It doesn't care. Again, sine, cosine, and tangent are going to be different, but they're all trigonometric functions. So those are all the basic things. And if we know what the basic things look like, so y equals x squared is that parabola. Y equals root of x is that graph where that keeps growing on and on forever. So just like the parabola keeps going up, that's again the parent function. Y equals absolute value of x. It comes in at a 45-degree angle, right? And leaves both those things. And y equals sine x. Sine starts at the origin and goes up and down just like that, right? Its high point is 1, its low point is -1, and you guys know that it repeats the entire process in 2 pi or 360 degrees, right? And of course, it keeps going back like this. It's a continuous function. It goes on and on forever, just repeating that same thing. So then the question is, what do some of these craziest transformations do to it? So we're going to talk about some of them. I probably won't do them all, but we're going to talk about some of these ones. And again, I'll probably go through Desmos a lot. I don't have my iPad here right now, but if I did, you'd be like, whoa, okay. So this one right here. So y equals square root of x minus 3 squared plus 6. Well, according to my things, if there's a plus or a minus inside the parentheses, that's going to move stuff left or right, and it depends on what it is. So since this is a minus 3, it should take this parabola and move it 3 to the right. This is a plus 6. It's going to move it up or down. So sorry, I should put this on here. Plus moves it up, a minus moves it down. So the stuff on the outsides does exactly as what you would think. Stuff on the insides would actually is going to do the opposite. So this would be a parabola that is moved 3 units to the right and 6 units up. It doesn't get wider or skinnier, vertical or horizontal stretches, because there's nothing multiplying out in front or directly to the x. Okay? So this one right here, this would be one that moves 4 units to the right and 8 units up, but it's also got a negative sign out in front. Well, a negative sign, what does a negative sign out in front do? Negative sign looks like it flips it over the x-axis right there. It's negative out inside of that function. Okay? Kind of good with that. So let's take a look at a couple of these ones here just to see that what I've been saying is exactly what's going on. So let's do the first one. So y equals x squared. There's our generic one. And then y equals parentheses x minus 3 parentheses squared plus 6. Okay, so there's my graph of my first one, and then there's my graph of my second one. We said it was supposed to move 3 units to the right, 6 units up, and it does it. We're like, yay, that worked. So let's go down to number 2 and see what we got here. So negative parentheses x minus 4 close parentheses squared plus 8. Oops, sorry. We'll start all over again on that. That'll give you time to catch up in case I was going too fast. X minus 4 close parentheses squared plus 8. So you can see there's my original one, and there's my other one. So again, the shifting goes 4 units to the right and 8 units up, and then it should be a reflection. Well, that reflection happens over that point of the vertices, so it doesn't flip it, the entire thing over the x-axis all the way down here, unless we put this whole thing in parentheses. We're just doing it in this spot right here. Okay, so let's go do a couple more of these ones here. So I got this one, y equals square root of x minus 5 plus 6. So it should be a square root function. We'll take a look at that. Y equals root of x, enter, and hit graph. You can see it, that just looks like that. So now this one should be the square root of x minus 5. Outside the parentheses is the plus 6, so plus 6. So again, I think this is going to move it 5 units to the right and then 6 units up. When I hit graph, you can see it's 5 units right and 6 units up. That's where its new starting place is. Okay. Now, if I was to put a big number out there in front of it, watch this. Like clear, like this one. Let's do an 8 out in front, square root of x, like this. That's a k times that function, so if I hit the graph like this, you're going to see the next one. Like, what the heck? So let's just focus in on that section of it. So I'm going to go x min 0, y max, or x max 20, y min 0, y max 20, so we can just see it. And you can see that this one was a big vertical stretch. It stretched it vertically, so instead of going as flat as what it did, it went way up. Okay, now if I was to make that a 1/8, so I'm going to insert a 1 divided by, so it's 1/8 out in front of that thing, and I hit graph. There's the first one. Now you can see the second one, so that's a vertical shrink, so it squished it way down. Okay, so let's do this next one here, number 4. So here's my original, y equals square root of x, and now I'm going to do square root of negative x, and then remember, move your cursor to the right so it's outside the parentheses, minus 3. And I go to the graph, oops, sorry, zoom 6 this sucker, zoom 6. So now you can see this is a reflection over the y-axis, right? When I change the x itself, make the x negative, it flips it over the y-axis. Now that vertical shift is 3 units down, so the new part starts 3 units down and it flips it over just like that. Okay. I'm going to skip some of these ones because they're similar to what's going on and what I've already said. So let's go all the way to number 8 because that's a different type of graph. So that's an absolute value function. So I'm going to go clear, y equals clear and clear. So I do absolute value. So that's under the math key. So math, and then num, that's the first one, number 1, absolute value of x. And I'm going to go ahead and hit graph. You guys can see that is the absolute value. It's a straight line that goes all the way down here, right? Y equals, let me show you this. Maybe this will help. Y equals x is this line, but it just simply means every part of that line that was negative is now positive. So that's why it breaks right there and flips straight up. Okay? So now we're doing some things to it. So we're putting a 4 out in front. So 4, math, num, absolute. I got 2x minus 5, 2x minus 5. Move that over, and then I got a plus 7. Just like that. Good deal. So then I go ahead and hit my graph, and you're like, what the heck? Why is that? Let me go higher for you. Y max 20. First off, why does it look like that? Well, the new vertex you can see has been shifted. So you're like, okay, well, what does that point at? Let me hit trace and get me a point here on this thing. It looks like that point's almost at about 2.5. If I look carefully at that, it's almost at about 2.5. So why is that at 2.5? Well, it's at 2.5 because I'm looking for the 0 of the inside of this thing. So the opposite of negative 5 is 5. 5 divided by 2 is 2.5. So it's been moved 2.5 to the right, right? This would be 5 to the right, but I got to cut that in half. So 2.5 to the right and up 7. And that's what takes us to there. And then what's going on with this? Well, this was normal x, and now it's got a big 4 out in front of it, a big 4 out in front of it. So that's a vertical stretch. Whereas, again, if I inserted here a 1 divided by and made that a 1/4 in front, you would see that that sucker is going to get really flat compared to the other one. That would be a vertical shrink. Cool. Okay, and last one, just because I'd like to play with these ones, and I feel like you need to see some of these ones. 14 sine x plus 7. So I'm going to do sine x first. Sine x, graph just like that. And when I go to graph it, I want to make sure I get a sine wave. Now, if you didn't have a nice sine wave just like this, and let me go ahead and do zoom 6. If you didn't get a nice sine wave that looks like that, then one of the issues could be that your mode is off. So if you click on mode, you might be in degree mode, and I'm in radian mode. So I'm going to keep it in radian mode, switch yours to radian mode so that we have that. Good deal. So we'll go through this. So now I have sine of x, right, plus 7. So I'm going to do these independently, sine of x plus 7. You can see that simply taking the sine wave and shoving that up 7. Yes? Whereas if I went here, and we'll do these later for you too, plus 2 and sine x, you're going to see that they're slightly different. It kind of looks like a helix, right? So, but watch what happens when I do this to pi, parentheses, and a graph. So there's my blue one. And you can see that those are identical. It's just been shifted 2 pi, and we said that's what it does, is it repeats every 2 pi. So again, that's my horizontal change, and my vertical change was from before. So what does a 14 do in front? Well, it's supposed to be, if a number's out in front, it's supposed to be a vertical stretch, right? Vertical stretch. So let's do 14 sine of x. And look at that. Like, whoa! It really stretched it up way big. That is quite a vertical stretch. Okay. So then if I did the final thing, 14x sine x plus 7, you can see that that starts way up high, and a lot of it goes off the screen. So hopefully this information here was a good start for you on some of this stuff, and that should be able to help you answer the questions on it. Again, I won't always use this thing. I'll talk about it getting skinny or getting wider or getting narrower or flatter, those types of terminology. But flipping over the x, flipping over the y, moving it left, moving it right, moving it up, moving it down, being able to basically transform some of those functions. Good deal. Okay, we will talk to you guys later. Thank you much. Bye.